Hello guys, we're almost done with our unit 3 on multiplication. So let's get started with lesson 3.9, which is just multiplying more numbers. So here's our first one. So we have a road repair crew can usually fix 825 potholes each week. How many potholes can they fix in 6 weeks? Well, we have a model, so let's draw a model. And we have 1, 2, 3, 4, 5, 6 weeks. So just so we have that labeled. And then how much can they fix in each week? 825. That means each of these boxes are 825. So we could add that 6 times, or we can use multiplication. So let's use multiplication. So I'm going to use the standard algorithm for this one, but I'm also going to switch back and forth between our standard algorithm and partial products. So our first one is 6 times 5 is 30. So I put that 0 down, regroup that 3. 6 times 12, or 6 times 2 is 12, plus 3 is 15. So I write that 5 down, carry the 1. 6 times 8 is 48, plus 1 is 49. So how many potholes? Well, that looks like it's 4,950. So now let's head on to number 2. Oh, but let me put that label since it is a word problem. A tire shop sells 3 tires that costs $175 each, which includes a 4th tire for free. Is it more or less expensive than buying 4 tires for $135? Let's see. Let's buy those 3 tires and get the 4th one free. So 175 times 3, and this one I'm going to use partial products. So we have 3 times 5 is 15. 3 times 70, so I start in that tens place value, is 21 plus that 0, and our last one, 3 times 1 is 3. I start that hundreds place value, so this is my hundreds, and add those 2 zeros. So now let's add them up, 5, 2, 5. So this one is going to cost 525. So let's see how much it is for 4 tires at 135. So again, I'm going to use partial products for this. So 4 times 5 is 20. Start in my tens place value, so I add that 0 to start in the tens place value. 4 times 3 is 12. And then lastly, we start in the hundreds place value, so I start in my hundreds, which means I put 2 zeros. 4 times 1 is 4. So adding them up, I get 540. So which one is cheaper? Well, it looks like the 4th tire free is cheaper. So we're going to say buying 3 and getting the 4th free is cheaper. Okay, let's head to our practice problems over here. Find each product. 6 times 4 is 24. 6 times 7 is 42, and since I'm in my tens place value, I start in my tens place value. When I add them up, I get 444, a whole bunch of 4s. Number 4, we're going to use our standard algorithm. 5 times 9 is 45, so I put that 5 down, regroup the 4. 5 times 1 is 5, plus 4 is 9. Nothing to regroup, so 5 times 8 is 40. 4,095. Okay, so here we're going to start. Remember, I'm always going to rewrite it as they're stacked. 4 times 9 is 36. 4 times 0 is 0, which made it easy. And then our last one, 4 times 3 is 12. And since I'm in a hundreds place value, I put those 2 zeros. Add them up, I get 1,236. Here's our next one now. 3 times 5 is 15. Regroup that 1. 3 times 7 is 21. Plus 1 is 22. So I put the 2 here. Regroup that 2. And lastly, 3 times 1 is 3. Plus 2 is 5 for 525. Number 7, rewriting it. And I'm going to use my standard algorithm of 8 times 8 is 64. So I put that 6 down, regroup the 6. 8 times 1 is 8, plus 6 is 14. So write that 4, regroup the 1. And then 8 times 2 is 12, plus 1 is 17, 1,744. Okay, our next one, regrouping, and I'm going to use the standard for this one. 6 times 1 is 6. 6 times 4 is 24, so I put that 4 down, regroup the 2. 6 times 7 is 42, plus 1, or plus 2 is 44, so write that 4 and regroup the 4. And lastly, 6 times 1 is 6, plus 4 is 10, for 10,446. Let's stack them, but this one they made it so the big number was on the left, so I'm going to write our times underneath. 7 times 9 is 63 for my partial products. So now I go to my tens place value. So I add a 0, so I can start writing that tens. 7 times 2 is 14. So now I can add them up, and I get 203. Our last one for this section, we're going to use partial products. 9 times 1 is 9. 9 times the tens place value, so I put a 0 so I can start on the tens. 9 times 6 is 54. Now I go to my hundreds place value, so I add 2 zeros so I can start writing that hundreds place value. 9 times 4 is 36. And our last one, 9 times thousands, so I'm going to start at thousands place value. So I put zeros, so I start on the thousands place value. 9 times 1 is 9. And now I can add them up. Look how colorful that one is. 9, 4, 11, regroup the 1, 13, 13,149. So now we have a whole bunch of these problems over here. All right. 6 times 7 is 42. 6 times 7 is 42, and I put that 0 so I start on the hundreds place value. 462. Checking with estimation, this would be 8 times 6 is 48, so 480. My estimation I'm going to write over here, 80 times 5 is 400, so our answer should be close to 400. 5 times 3 is 15, regroup that 1. 5 times 8 is 40, plus 1 is 41. And my answers were close, so I'm good. 60 times 4 is my estimation, so my answer should be close to 240. 4 times 2 is 8 for partial products, and then 4 times 6, or 4 times 60 is 240. So adding those up, I get 248, and notice my answers are close to each other. Our next one, we'll use our standard algorithm. This is close to 90 times 7, so my answer should be close to 630. 9 times 7 is 63, with that's 6 regrouped. 7 times 8 is 56, plus 6 is 62. So I'm in my 10, oops, I forgot which, I guess I'm doing partial products. It's 62, I couldn't remember which one that is that I was doing. So 683. So now let's check. Is that close? Yes. But I actually realized that there's a mistake somewhere. So it doesn't always connect, even if it's close. So let's see what our mistake was. So I'm going to start all the way over. Remember, it is perfectly okay to start over. 7 times 9 is 63, so I'm going to put that 3 down, regroup that 6. 7 times 8 is 56, plus 6 is 62. So what my mistake was I regrouped up here, but then I did partial products down here, and I made that a 62 when I had a 63 here. So make sure you don't get your processes mixed up like I just did. Okay, number 15 now. 3 times 5 is 15, start at my tens place value. 3 times 4 is 12. And then last one, my hundreds place value, so 3 times 2 is 6. Add them up, and I get 735, which is close to 250 times 3 for 750. Our next one, this is close to 300 times 9, so it should be close to 2,700. 9 times 8 is 72. 9 times 1 is 9, plus 7 is 16, so I regroup that one. 9 times 3 is 27, plus 1 is 28. Notice how my answers are close to each other, so it is correct. This is close to 700 times 2, which is 1,400. 2 times 6 is 12, so I'm using partial products. Now I'm in my tens place value, so I add a 0. 2 times 3 is 6. I'm in my hundreds place value lastly, so I put 2 zeros down. 2 times 7 is 14. 2714. So 14,072, which is close to my estimate. Number 18 now. So we're almost halfway done. 8 times 4 is 32, so I'm going to put that 2 there, regroup the 3. 8 times 1 is 8, plus 3 is 11, so I put a 1 down, regroup that 1. 8 times 3 is 24, plus 1 is 25. So now let's check our estimate to see if it's close. This is close to 300 times 8, which is 2,400. So our answers are close, which means my answer is probably correct. So I can move on. So here I'm now going to rewrite it. I'm going to use partial products. 4 times 7 is 28. Now I'm in my tens place value, so I put that 0. 4 times 4 is 16. I'm in my hundreds place value next, so I put 2 zeros. 4 times 3 is 12. And lastly, I'm in my thousands place value, so I put 3 zeros, so I start at my thousands. 4 times 4 is 16. So now I can add them up. 8, 8, 3, 7, 1, 17,388. This is close to 4,000 times 4, which should be close to 16,000. So my answers check out since they are reasonable. They're close to each other. Now let's stack them. And we're going to use our standard. 6 times 6 is 36, so I put the 6 down, regroup the 3. 6 times 1 is 6, plus 3 is 9. My last one, 6 times 7 is 42, so I put the 2 down, regroup the 4. 6 times 6 is 12, plus 4 is 16. So let's check. This is close to 3,000 times 6, so my answer should be close to 18,000, which it is. 16 is close to 18, so we can move on. Number 21, we're going to use partial products. 7 times 7 is 49. And since I always know I'm going by my place values, I can actually put my zeros in right now, if that helps me remember. Because notice now I'm going to start on the place value I should every time. 7 times 8 is 56. My next one is 7 times 2 is 14. And lastly, 7 times 1 is 7. So let's add them up, see what we get. We get 9,009, and let's check our estimate. So this is close to 1,000 times 7, which is 7,000. So it's close. 7 is close to 9, so I think my answer is good to move on. We're going to use our standard algorithm, and first we're just going to use our estimation. This is close to 2,000 times 3, so our answer should be close to 6,000. Let's find out. 3 times 2 is 6, nothing to regroup. 3 times 4 is 12, so I put a 2 down, regroup the 1. 3 times 9 is 27, plus 1 is 28, so I regroup that 2. And lastly, 3 times 1 is 3, plus 2 is 5. 5,826, yes, that is close to 6,000. Our last ones for these problems. So again, we're going to stack them. And now let's do our estimation. This would be 2,000 times 5, which is close to 10,000. So we now have 5 times 49. I'm going to use my partial products, 45. And I'm going to put those zeros in to start with. So now I can just multiply and add my answer. 5 times 1 is 5. 5 times 3 is 15. And lastly, 5 times 2 is 10. So when we add them up, it's 11,559, which is close to that 10,000. Our next one is a 5 as well, which was nice of them. Our answer should be close to 5,000, 1,000 times 5, and we're going to use partial product or standard algorithm. 5 times 7 is 35, so I put the 5 down, regroup the 3. 5 times 6 is 30, plus 3 is 33. So I regroup that 3. 5 times 4 is 20, plus 3 is 23, so I put a 3 down, regroup the 2, and 5 times 1 is 5, plus 2 is 7. 7,000, which is close to our answer 5,000. Maybe not as close as we'd like, but it's close. 2 more, guys. So we have 9 times 2,000, so our answer should be close to 8,000. And we're going to use partial products. So let's put our zeros in right now. 9 times 8 is 72. 9 times 3 is 27. 9 times 1 is 9. And 9 times 2 is 18. So now let's add them up. 19,242, which is close to 18,000. And our last one. Our answer should be close to 50,000 because we have 10,000 times 5, and we're going to do our standard algorithm. 5 times 9 is 45, so I put the 5 down, regroup the 4. 5 times 4 is 20, plus 4 is 24, so I put the 4 down, regroup the 2. 5 times 7 is 35, plus 2 is 37, so I regroup that 3. And lastly, 5 times 9 is 45, plus 3 is 48. 48,745. So now let's go to our word problems. Maru's, I think that's how we say his name. Maru's dance team wants to buy costumes that cost $56 each. They have $523 saved in a fund. How much money will they have left in the fund after they buy 9 costumes? Well, here's my model, because with those word problems I always like that. And I see they're buying 9, so that means I should have 9 boxes. 1, 2, 3, 4, 5, 6, 7, 8, and 9. So they're all going to cost $56. So I could do 56 plus 56 plus 56 9 times, or I can do 9 times 56. So let's do that part. And I'm going to use my partial products. 9 times 6 is 54. 9 times 5 is 45. So how much are these costumes going to cost? They're going to cost $504. But that's actually not what the question's asking. It's saying, how much money will they have left? So I'm starting with this, and they have to get this much. So we will have 523 minus 504. That's how much money they're going to have remaining. So let's regroup, and it jumped me to the top. So let's regroup. So they're going to have $19 left. Not a lot. 28 now. Elaine rents a car for 5 days. It costs $4 each day to rent a car and $7 each day for insurance. At the end of the trip, she spends $35 to fill the car with gas. What is the total cost? Well, let's see how much it costs for 1 day. So 1 day is 44 plus 7. So what is that? That is 44 plus 7. 1 day, it costs her $51. So now we know it costs her $51 a day with the insurance and the rental. So she's renting it for 5 days. So we're going to multiply it by 5. We're making 5 equal groups, 5 days. So we have 5 times 1 is 5. 5 times 5 is 25. So that's how much the car rental costs. And then lastly, it tells us she's adding $35 worth of gas. So let's add $35, and then we'll see how much this car costs for 5 days. $290. That's like a whole month of a car payment. Now let's head to problem 29. At the math club ceremony, there were 17 tables with 8 people seated at each table. Each guest received 2 certificates. How many certificates were distributed at the ceremony? Well, what this is we have 17 tables. So if we're doing a bar diagram, we break it up into 17 pieces. And each one would have 8 at it. So let's figure out what that is. 17 times 8. And we're going to use the standard. So 8 times 7 is 56. Regroup that 5. 8 times 1 is 8 plus 5 is 13. But that's not how many they got, because notice it says this math club really likes certificates. Everyone got 2. So we have 136 now times 2. There's 136 people, and they all got 2 certificates. So we have 2 times 6 is 12. Regroup that 1. 2 times 3 is 6, plus 1 is 7. And 2 times 2, or 2 times 1 is 2. So how many certificates? There are 272 certificates. Now let's head on to number 30. Water erupting from geysers can reach a temperature of 244 degrees Fahrenheit. The average temperature in Yellowstone National Park is 35 degrees. Use compensation to calculate the difference between these 2 temperatures. Now, if you remember what compensation is, that's like where you take and add away to make these friendly numbers. We could do that. I'm just going to use our standard, so I'm just going to ignore this. It is okay, because our whole purpose is for you to figure out strategies that you like. I'll show you compensation after we solve it our standard way and see if you like that one better. So it's going to be 209. What we could do is for compensation, we would add 1 to 244, which would give us 245. But if we add 1 there, what does that mean? It means we have to add 1, or we have to take away that 1 after we do subtraction. So we would subtract that 35, which gives us 210, so that was easy to do. But now we have to take away this 1 that we did up here. And you'll notice our answers are the same. I personally will use that standard one though, almost every single time. Okay, number 31. On Monday, Palo sold 21 tickets to the dance. On Tuesday, he sold 3 times as many as he sold on Monday. On Wednesday, he sold twice as many tickets as he sold on Tuesday. How many tickets did Palo sell in 3 days? Well, his first day sold 21, so let's put that here. This is day 1. Day 2, he sold 3 times 21 because he sold 3 times as many. So let's find out what that is. 21 times 3. So let's zoom in. That's going to be 63. So now that I know it's 63, I'm going to fill in day 2 with 63. It told me on day 3 he sold, man, a busy person, he sold twice as much. So it's 2 times 63. So what is that? 63 times 2 is 6. He sold 126. So let's fill this in. Now this isn't just our answer because we have to figure out the total amount that he sold. So we have to add all these up together. So we have 126 plus 63 plus 21. So let's add them. This is going to be 10. This will be 11, so I regrouped that one. So he sold 210 tickets. Okay, now let's head to our very last problem. Mr. Tran would like to buy a new sofa that costs $934. He can pay the total all at once, or he can make a $125 payment each month for 8 months. Which plan costs less? Well, let's find out. If he does this, the 8 months, it's going to be 125. Let's zoom in. Times 8. So that's going to be, I'll do my standard. That is 40, so I regroup the 4. 16 plus 4 is 20, so regroup that 2. 8 times 1 is 8, plus 2 is 10. So it's going to cost him $10,000. I'm sorry, that'd be more. It's going to cost him $1,000. So now, we notice it's going to be less if he pays all at once. But we have to do this explanation. So let's explain it now. It costs less to pay the total all at once. It costs $1,000 for the monthly plan, but only $934 for the sofa if he pays all at once, which is a difference of 66. Good job, guys. I know this one was a long one.